Hi guys, so before we begin today's video, I just wanted to make sure that you got a chance to look at the front. Your trimester exam ends your trimester 2 ends next Friday. So that means you're going to have a math exam in a few weeks. It will cover all material from trimester 1 and trimester 2, right? However, it will have more T2 questions. So here are the units we've done so far this year, and in the bolded are the units we've done in trimester 2. So those will be the majority of your test, but you will see things from units 1 and units 2. Okay? So here is your calendar. So we are going to continue doing the unit on functions, and we are going to have a mid-unit assessment on the 6th. All right, we also have our little mini lesson quizzes on Thursday this week and Tuesday next week. And then Wednesday will be in a whole period assessment. All right, and then on the 7th and 8th, we'll review for your trimester exams. And then that's it. Okay, so let's get to today's lesson. Okay, so this video is due Wednesday. It is on comparing linear and nonlinear functions. So there are two main concepts we're going to talk about this week. This first one, we started before, let me change my pen color. We started before break. All right, so this will be a recap. And then what is new, but we already know a lot of this stuff, this is going to be add-ons, is comparing the rate of change and comparing the initial value. Now, rate of change is the same thing as slope, and your initial value is the same thing as your y-intercept. All right, and those two words we learned last unit, so that is going to help us with this unit. All right, so to tell whether a function is linear or nonlinear, we need to see, one, linear functions, they are straight, and they have a constant rate of change, and that means it adds or subtracts by the same number. So that's what we're checking for. Okay, so first we check function A. I see that it goes up 1, and then it goes up 3, and then it goes up 5. This means that it is not constant, so it would be not straight, and when things aren't straight, it means it's non-linear. All right, so I'm going to start with that sentence. So function A is non-linear because it is, let's be specific. Because the y values are not constant. All right, function B, I can just see by observing, and I can see that it is straight. So that means it is linear. All right, so I'm going to write my second sentence. Function B is linear because it is a straight line. All right. So now this question says two linear functions are shown below. So they're telling us that they're linear. Which function has the greater rate of change? So what does that mean? Greater rate of change means which one has the biggest slope. All right, and remember there are two ways to find slope. So first, from a table, I can pick my 2 points. And I can figure out my change in y, which is 3. And my change in x is 2. And Then I do my change in y divided by my change in x. 3 divided by 2, and that gives me 1.5. Okay? From the graph, I can do the same thing, or I can just count my boxes. So I can see that my change in x from one point to the next is plus 1, and my change in y is also plus 1. But I need to be careful about I'm going to erase this and try to explain that again. I need to be careful about how much it's counting up by. So what I like to do is I like to look at these numbers down here. It's going from 1 to 2, so that means it's going up 1. That's my change in x. Then I do the same thing for my numbers on the side, and it's going from 3 to 4. That's also plus 1. That's my change in y. So my change in y divided by my change in x is equal to 1. All right, so which one is greater? Which one has the bigger slope? So when I look at those two numbers, I see that function b is bigger because it's 1.5. So I would say function b has the greater rate of change because 1.5 is bigger than 1. All right, that's it. As always, if you have any questions, please make sure to write them in the end of the video.